Hey students, myself Irfan Sir and you are watching Irfan Sir's Academy. We will discuss the magnetic field due to a current carrying circular coil. We have given a current carrying circular coil and we have to calculate what is the magnetic field due to this current carrying circular coil. Suppose we have a current carrying circular coil. This is current carrying circular coil and it carries a current I in the direction as shown. So this is the direction of the current. This is the direction of the current. Here we take clockwise direction of the current. I is the current through this. The radius of this circular coil, suppose this is R, small r. Now we have to calculate what is the magnetic field due to this whole circular coil at the center of this circular coil. Let suppose center is O. What we'll do, we'll first using BIOT-SAVART law, we'll first calculate what is the magnetic field due to the small current element. Suppose that small current element, it is DL. DL is small current element. We will find what will be the magnetic field at the center. This is the current element. IDL will be the current element, and DL is a small element of this wire, because the wire is supposed to be made up of small this elements DL, and the current elements it will be IDL. This is at a distance of R. What will be the magnetic field? Magnetic field due to current element. What's the current element? That's IDL at the center of coil. What will be the magnetic field at the center of the coil? Using BIOT-SAVART law, that will be small magnetic field, that will be equal to mu naught upon 4 pi. What's the current in this? That's I, that's TL, in sine of the angle between this current element and the position vector of this current element, or the position vector of this origin, this point O from this current element, upon what's the distance between, that's R square. You can also calculate using vector form. You can write this as mu naught upon 4 pi I dl cross R upon R cube. That thing we have seen in the previous sections, how we can calculate this in vector form. Now we will see here what will be dB. What is the angle between at every section, at every current element? The angle between the radius and this current, it will be 90 degrees. What will be sine 90 degrees? That will be equal to 1. It will be mu naught upon 4 pi I dl sine 90 degrees. That will be equal to 1 upon R square. This will be the magnetic field at the center of this circular current carrying conductor, small due to this small current element. Now we know that these current elements, these are continuous in the coil. At all the current elements will constitute the magnetic field intensity at the center. Now total magnetic field, it will be by integrating. What will be the total magnetic field B? It will be integration of dB. Now how we can calculate? That's B, very simple. What's dB? That's mu naught upon 4 pi. It will be I dl sine theta, that's equal to 1 R square. And it will become mu naught is constant, I is the constant current, 4 pi, R is the radius, that's constant, it will be dl. This mu naught I upon 4 pi R square. What will be the integration of dl? It will be total length of this. Total length means here the circumference of the coil, and it will be equal to 2 pi R. And pi will cancel out, 2 1 R, 2 R. It will be mu naught I upon 2 R, 1 R will cancel out. It will be mu naught I upon 2 R. This will be the total magnetic field due to this current element. Due to holes current carrying circular coil due to small current. This is the answer. Now what will be the direction of this current element? That if we calculate the direction of this vector dB, it will be given by right hand thumb rule. It will be perpendicular to the plane. What will the current is clockwise? It will be perpendicular to the plane, and thumb will give the direction. Thumb will give that it will be perpendicular to this plane in which this coil. Suppose this board is a plane, and in this plane this coil lies. What will be the direction of magnetic field? Perpendicular to this plane, that's perpendicular to this board in which this coil is lying, and it will be inverse. The thumb will give the direction. If the current is supposed to be clockwise, it will be perpendicular to the plane and it will be outwards. Also, the direction of magnetic field at the center, due to whole current carrying conductor, circular current carrying conductor at the center, this can be also given by right hand thumb. Suppose if we have n number of turns, B will be equal to, if you calculate here, it will be mu naught I upon 2r into n, small n is the number of turns, it will be mu naught n into I upon 2r. This will be the magnetic field at the center of the current carrying circular coil at the center in which there are n number of turns. If the more this is the number of turns, more will be the magnetic field. More is the current, more will be the magnetic field. And if you go at the center, the magnetic field, it will be constant at the center because the distance that will be equal to r. At the center it will be uniform. And if we change the distance r, if you go from the center by decreasing r, magnetic field will increase. By increasing r, magnetic field will decrease. And it will be uniform, and it will be smaller at the center and it will be larger near the ends. If we see what will be the pattern of the magnetic lines of force, it will be perpendicular to the plane and these will be concentric circles. It will be like this, perpendicular concentric circles. Like if this is the direction of current, it will be like this. These will be the concentric circles. And it will be uniform if the radius of this current, if the direction of the current is in this direction, it will be in this direction. It will be in this direction. If the radius is very large, the magnetic field at the center due to this current carrying circular coil, it will be uniform at the center. If we go away from the center, the magnetic field will go on increase and it will be maximum. The magnetic lines of force will be crowded near the ends. If we see here also, the current, it is clockwise. If the current is clockwise, if thumb will point in the direction of current at the ends, what will magnetic field? Curling of your fingers will give the magnetic field. What will be the where will be the curling? Curl will be like this. It will be concentric circles, and also here it will be concentric circle. And if we see, it will be it will be perpendicular to the plane. If the current it is clockwise, it will be perpendicular to the plane inwards. If the current is anti-clockwise or counterclockwise, it will be perpendicular to the plane and it will be outwards. Is that clear? We can also write this expression as this magnetic field B. We can calculate here as mu naught I upon 4 pi r square into 2 pi r. For n number of times, it will be small n. 1 r will go cancel out. It will be mu naught I upon, what will be this? It will be 4 pi r. 2 pi n. What is 2 pi? It's angle subtended. Angle subtended by the coil. Angle subtended by the coil at center. If you know the angle subtended, you can calculate what will be the magnetic field. This expression will be very useful in calculate what is the magnetic field due to quarter, what is the magnetic field due to semicircle, what is the magnetic field if due to a circular arc, if you have given the what is the angle subtended by that arc. Very important as far as your competitive examinations are concerned. I hope you understand. Thank you.